Hello, Algebra people. Welcome to the Unit 4 review video. Today is May 4th. May the 4th be with you. It is Star Wars Day, and we're going to do a very, and I mean very quick review of the concepts that we learned in Unit 4. There was a lot in this unit. This was writing linear equations, and you had to know how to write linear equations in about 11 million different ways. So let's go through and talk about all those different things. The first thing you had to be able to do was write equations given a graph. So with a graph like the one that you see here, there are two possible scenarios. Either you can see that the y-intercept is an integer or it's not. So let's talk about if the y-intercept is an integer. We're going to use y equals mx plus b. And the y-intercept is right here. It is the number 4. So I know that my y-intercept is going to be plus 4. My question is, what is the slope? So remember, what you do is you find another point on the graph where the line crosses through the grid. So for example, right here, right here, right here, right here, and you choose any two of those points. You start at the bottom one, you count up, that's your rise, you count over, that's your run. Remember, if you go to the right, it's going to be positive. If you go to the left, it's going to be negative. So if I choose this point here and this point here, I go up 2 over 1. That means my slope is 2 over 1. But hello, we'd never write 2 over 1. We would just write straight up 2. So the equation would be y equals 2x plus 4. Now, just to remind you that you can use any 2 points on the graph. Let's say that I used this one on the x-axis and the one way up top here. If I count up 1, 2, 3, 4 over 2, that gives me 4 over 2, which, shocker, simplifies also to 2. So it doesn't matter which 2 points you use, you're going to get an answer of 2 if you do it right. Here is your equation. Now, it's a little bit more complicated if your y-intercept is not an integer. Let me zoom way in here, and can you see right here how where we're crossing the y-integer, it's not at 0 and it's not at 0.5. Like, I don't know exactly what the number is. It's some mystery number. We are not going to guess in this situation. We are going to use a different method. So let's get this graph out of the way for a second. If I don't know what the y-intercept is, then I have to use the point slope formula, or form rather, of the equation, which is y minus y1 equals the slope times x minus x1. So I need two things to do this. I need the slope, and I need one of the points. All right, so I'm going to say, it looks to me that this and this, I'm just going to say that these are integers. It's close enough. And I need to do rise over run. Now here's where we have to be careful. And let me zoom into this again. My dots are probably not going to stay, but that's okay. I'll erase those. You must look at the notations on the x and y axis to know how many up you're going and how many over you're going. A lot of you would start here to here and you would count up 1, 2. Except if I go from 1 to 2, that's really only rising up 1 because I'm going in half space increments. If I go from here to here, this looks like 2, but it's really 1 because if I'm going from 1 to 2, that's only 1, okay? And so my slope would be 1 divided by 1, which is 1. Now it just so happens on this case that this is up 2 over 2, which would also equal 1, but that's because both the x and y axes are going by half increments. Sometimes you'll have a situation where the x-axis, say for example, goes up by halves like this one, but the y-axis goes up, let's say if it went up by quarters. Okay, if it did like this, you're not going to be able to count 1, 2, 1, 2. You can't count the blocks. You have to actually look at where you start and where you end and see what the difference is. So be super careful on a situation like that. Let me reduce this down. Let me erase all this stuff. Sing a little song. Okay. Let me widen this up a little bit. Okay, so we just said that our slope is 1. So we need a point. I'll just use this point right here. And that point is 1, 1. 1.0, 1.0. Use a point that's easy, guys, okay? So y minus y1 equals the slope times x minus x1. All right, and then what we just do is simplify. First thing you have to do is the distributive property, so leave the y minus 1 alone. This is going to be 1x minus 1. Then we're going to do the inverse operations. Wow, inverse operations to get y by itself. And we get that this is y is just equal to 1x, which we would say is y is equal to x, okay? If you have a point, or if you have a graph where the y-intercept is not an integer, you have to use the point slope form. All right, let's move on to the next thing. What if here we are again, you have an equation given a point and the slope. So we don't have the graph this time, but we're going to do the same thing we just did. So y minus y1 equals m times x minus x1. So in this situation, y minus, now y1 is 7. There we go. Slope is -2. X minus. Now, x1 is -3. This minus sign is not the same thing as that negative. All right, those are separate from each other. You are subtracting a negative. Both of those symbols have to be there. And when you have minus minus, that really means plus. So you can change this before you keep going. Sorry. Now the next thing is to simplify using the distributive property and to get rid of that -7. And here's the equation of your line. Be careful with those double negatives. Next thing you had to do is write an equation given 2 points. Well, we're always going to go back to the point slope formula. But what do we not have here? We don't have the slope. So what I need to do is I need to use the slope formula to find the slope first. So imagining that these 2 points are on a graph, if you subtract y2 minus y1, if you find the difference in the y's, you're finding the rise. And if you do x2 minus x1, you're finding the difference in the x's, which is the run. So again, be very careful with these negatives here. y2, there we go, minus y1, this is a negative, over x2 minus x1, and be careful, that's another negative. So this is really 1 plus 4 over 3 plus 4, which gives us 5/7. So this is what we're going to use for our slope. Now, in our point slope formula where we're using y1 and x1, you can choose either point, one or the other, but the y and the x have to come from the same point. I am going to make my life easy and not deal with these negatives. I'm going to use this point right here. Okay, so y minus y1 equals my slope times x minus x1. All right, same, distributive property. And then eliminate your x. Now, if you don't know how to do the fractions, you can let Desmos do this. 1 would be 7/7. And if I do -15/7 plus 7/7, I'm going to get -8/7. And there you go. There's your equation. Next thing you had to do is be able to write the equations of horizontal and vertical lines. So this is where a lot of people get confused about, is it x equals or is it y equals? You know that one of them is x equals the number and the other one is y equals a number, but it's very easy to get confused which is which. So if you can remember this, hoi vux, this basically tells you the answer. If you split this in half, h horizontal, O means the slope is 0, Y means the equation is going to be y equals something. Vux, V for vertical. U means the slope is undefined. And X means the equation is going to be X equals something. So let's take a look at the horizontal line. I know it's going to be Y equals something, and I just look and see where that line crosses the axis, and it's right there at -2. So Y equals -2. If I look on the other side at the vertical line, I just look and see where it crosses the axis. It's right here at 4. So X equals 4. Hoi vux. Moving on, we had to be able to write equations of lines that were parallel or perpendicular to a given line through a given point. So this requires that you remember something about slope and parallel and perpendicular lines. Remember that parallel lines are lines that never touch. If they never touch, that means they have to have the same angle, and if they have the same angle, that means they have the same slope. Perpendicular lines do cross, and they cross at an exact 90-degree angle, and they have opposite reciprocal slopes. So for parallel lines, if the slope of this top line was -2, the slope of the second line is also -2. For the bottom ones, if the slope of this line was -2, the other one would be positive 1/2. You take -2, which is -2/1, you reciprocal it, and then you change the sign, all right? Opposite reciprocals. So when you know that, this is fairly easy to do. So we want to create a line, the equation of a line that's parallel to this equation, -2x plus 6, and goes through the point 1, -2. Since it's parallel, I know that my slope is going to be -2, and I have a point. Guess what? I can use the point slope formula. Y minus y1 equals m times x minus x1. So here we go. Y minus y1 is -2. So if I subtract a negative, that means it's going to be positive. The slope is -2. X minus x1. All right. Distribute. And simplify. All right, now if I wanted to graph these two, y equals -2x plus 6, well, I know that it has to go through 6. And I know it's going to be, if the slope is -2, I can either go up 2 and over 1 or down 2 and over the other way 1. So it would be like this, down 2 over 1, down to, oh, no, wait a minute, that's wrong. It has to be negative slope. That means it has to go this way, down 2 over 1, down 2 over 1. Here's what that line would look like. And if we graph the other line, it should look like it is parallel. So if it says y equals 2x, what's missing? We don't have the y-intercept. That means the y-intercept is 0. This line goes through the origin. And my slope again is -2. So down 2 over 1, down 2 over 1, down 2 over 1. And there it is, parallel lines. Now for perpendicular lines, we're going to do the exact same thing, but we have to think for a second about the slope. If the slope of the current line is -2, that means the slope of my perpendicular line has to be positive 1/2. And then I'm going to use the same point that I used before. So y minus y1, slope times x minus x1. Remember y, if you subtract a -2, you get positive. My new slope now is 1/2. We're going to distribute. And we're going to subtract. All right, and 1/2 minus 2 is -2.5. If you want to do -2.5, that's fine with me. We'll be able to locate, pretty well locate the y-intercept there, okay? So if I were going to graph this, Let's graph the original line first. It's one we just had. All right. And the second one should be perpendicular. I've got a y-intercept of -2.5. I should have done this so that it worked out better, but that's okay because halves I can guesstimate. And then I need to go up 1 and over 2. So up 1 and over 2 would be here. Up 1 and over 2 would be right there. Up 1 and over 2 would be right there. So that is going to cross like this, and sure enough, we have a pretty nice looking right angle there. All right. Next up was the word problems. So for the word problems, you're going to use y equals mx plus b. You're going to use the point slope formula. You're going to use standard form. You're going to use all those things that we already know. The trick is reading the problem and deciding which one of those forms is the appropriate form to use for that problem. So first of all, for slope-intercept form, which we know is y equals mx plus b, you need to be given rate of change, that's your slope, and you need to be given a starting point. That's your y-intercept. Now, rate of change, most often in the problem, it's going to say per. So if we look at our problem here, Evan is going to the county fair this weekend. The admission is $5 and the cost per ride is 50 cents. If he has $20, write and solve a linear equation to see how many rides he can go on. So the admission is $5. This is what he has to start with. He's starting with the $5, and then he's going to keep riding rides until he runs out of money. And see, it says per. So there's your slope. So the equation would be y equals 0.5x plus 5. Now, if we know he has $20, that goes here where y is. That's total cost. Now what we can do is we can solve this equation to find out what x is equal to. So if I subtract 5, divide by half, we find out that Evan can ride 30 rides with his $20 form. So remember that standard form is ax plus by equals c. And so we're going to use this type of problem when the problem is talking about two completely different things. So let's look at our problem here. We have Sam. Sam ordered 2 hamburgers and 3 hot dogs from the concession stand at the baseball game. His bill came to $19.05. If hamburgers cost $5.25 each, write and solve a linear equation to find the cost of each hot dog. So what we need to do first thing is decide what's going to be A and what's going to be B. You should always define your variables so that you don't, when you're doing your equation and substituting numbers, you're not putting the wrong thing in the wrong place. So I'm going to let A be hamburgers and I'm going to let B be hot dogs. So if I start with ax plus by equals c, if A is hamburgers, I know that Sam had 2. And if B is hot dogs, I know that he had 3. This is the basic equation. Now, if we want to start substituting things and solving, we're going to start substituting the other numbers that we have. I know that the total bill came to $19.05. This is total cost. Hamburgers I know are $5.25 each. So 2 hamburgers times $5.25 plus 3 hot dogs times I don't know. This is what I'm finding. I'm finding the cost of each hot dog, so y stays. Now that we have one variable, we're just going to solve this and see what happens. So we have $10.50 here plus 3y. I'm going to subtract $10.50 on both sides. I'm running out of space here. $19.05 minus $10.50 is $8.55. I'm going to divide by 3. And I get $2.85. Remember that this is money. So here is our answer. Hot dogs are $2.85 each. Our third type of problem, word problem, is point and slope. And as we have done so many times before, we're going to use the point slope formula. So we're going to use this when the problem gives you an example point and the rate of change. So you know for rate of change, slope, you're usually looking for where it says per. So let's see here. At Eagle Bay, it costs $12 per hour, ding, 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 to rent a canoe. Nate and his friends rented a canoe for 4 hours and paid $68. Here is your example point, 4,68. Our slope is 12. Write and solve a linear equation to find the cost to rent the canoe for 7 hours. Okay, first thing we're going to do is substitute these two things into our point slope formula. Y minus y1 equals slope times x minus x1. And we're going to simplify it. Once we have this simplified, we can substitute in 7 to find out what our cost would be. 12 times 7 is 84. So that means, let's see, it would be $104 to rent the canoe for 7 hours. Okay, substitute into point, slope, and simplify, then substitute again to find your final answer. And finally, our last type of problem is word problem when we're given 2 points. And we know that what we're going to do is we're going to end up using the point slope formula again. But this time we're going to have to do some work to find the slope first because they're not giving it to us. We're going to use this problem when we're given 2 example scenarios. And the 2 scenarios are going to be our 2 xy and xy. So to surf the internet for 15 minutes at the airport, it costs $4.05. That is your first scenario. 15 minutes, 4.05. For 40 minutes, it costs $5.80. There's your second scenario. For 40 minutes, $5.80. Write and solve a linear equation to find the cost for surfing the web for 1 hour. So 1 hour is going to have to wait for a minute. First thing we need to do is find the slope here. So I'm going to use my slope formula. So y2, 580 minus y1 over x2 minus x1. Let's see, 580 minus 4.05. Whoops. I'm using my calculator on the side here, guys, rather than switch you back and forth to Desmos. 1.75 over 25. And that gives us, let's see, 1.75 divided by 25 is 0.07. All right. So x, our slope rather, is 0.07. Now, I'm going to get rid of this stuff. Now that I have that, I'm going to use the slope and one of these 2 points. I'm going to use the one with the smaller numbers just to make my life easier for math. And we're going to find out what it costs to surf the web for 1 hour. So we have to do our y minus y1 equals slope times x minus x1. This kind of problem takes the most writing. It's kind of annoying, but it is what it is. Oops, I wrote the wrong thing. So 4.05 is my y, 0.07 is my x, my slope rather, 15 is my x. So y minus 4.05 equals 0.07x minus, let's see what this is, times 15, 1.05 plus 4.05 plus 4.05, y equals 0.07x plus 3. Now that I have this, I can substitute my 1 hour. But here's the thing. When I was doing all these calculations, I wasn't talking about hours. I was talking about minutes. So this formula is good for minutes. So we're going to need to change our hour to minutes. So 0.07 times 60. All right, not times 1. And let's see what that is. Times 60 is 4.2 plus 3. That gives us 7.2, which is $7.20. All right. And guys, it makes sense. If 15 minutes is $4, 40 minutes is $5. 60 minutes should be more than that. Let's see what would happen if I put in a 1. It would be 0.07 plus 3, which would be $3.07, which doesn't make sense. It should cost more than that. This is why you got to be really careful not to get so caught up in the math that you forget what was actually happening. Always go back to the situation and ask yourself, does it make sense that my answer for an hour should be $3? When for 40 minutes it was $5. It should actually be more than that. Something happened. What did I not do right? Oh, I put an hour instead of 60 minutes. Always go back to the scenario and reread it to yourself. Okay, so there are the 4 types of word problems, and we have one more thing to go over, and that was the transformations. We did cover this a little bit in Unit 3, so we're going to just talk about it really super fast right now. The parent function of y equals x, remember, is the line that looks like this. It goes right through the origin, and it has a slope of 1. So for a translation, remember, if you want to do a translation, you are changing the y-intercept. That will move the line up or down. So you keep the slope, you keep the x the same, and you just add or subtract something. What if I do plus 5? That means my line is here, but it still has a slope of 1. All right, if you do a translation, your lines will be parallel. Dilation or rotation, you are changing your slope. This will tilt your line up or down. So if I go back to the parent function of y equals x, if I want to rotate it, I need to put a number, a coefficient in front of this x. Right now the slope is 1. So if I wanted to make it steeper, I would make a slope that's higher. If I wanted to make it shallower, I would make a slope that's lower. All right, let's go with 2x. I'm still going to be going through the origin because I didn't have a y-intercept, but now if I go up 2 and over 1, up 2 and over 1, up 2 and over 1, you can see that I have changed the steepness of my line. Okay. Finally, if you want to reflect a line, you're going to make the slope the opposite, the exact opposite. Not opposite reciprocal, just opposite. Remember, opposite reciprocal is going to give you a perpendicular line. If I want to reflect this red line, which was, remember, y equals 2x, I just change the slope to negative. Negative 2x would give me this. Okay. So the lines are not exactly, if you look at the, I'm going to make them both blue. If you look at the red line and if you look at the green line, they are not perpendicular. Look at the intersection here. They're not perpendicular, but they are an exact reflection. Okay. So you just change the slope and make it negative, not the opposite reciprocal, because that would be, what do you call it? Perpendicular. Okay. And that is everything we learned in Unit 4. Lots of stuff. I've got some note things that you can look at, so take a look at the documents if you need to as you go through the activities week. And if you have any questions, let me know.